I know these were longer videos than a lot of the other slides, but it is like a very complicated thing that is hard to do without doing it in person. So hopefully it's making a little bit more sense. If not, I'm going to keep stressing the importance of this in future lessons. Okay, so here hopefully you're able to figure out this is a positive slope just by simply looking, all right, is the rise going up or is it going down? And because it's going up, we know that it is a positive slope. All right, here we go. Final stretch. This I recommend writing down in your notes just for a reminder. While you're writing it down, I'm going to go over these graphs and calculate the slopes. Just a quick refresher. So right here, I move 5 seconds. I move 50 meters. The rise is 50. I'll just write rise over run over here just for your sake. Over 5. And you see, this is a velocity because it has meters per second as our units. Over here, you literally do the same exact thing as you did for the position versus time graph, only the difference is my face is covering this. Ugh. The only difference is this time, instead of giving 50 meters, we get 50 meters per second for our rise. So this causes us to have meters per second divided by seconds. And we know this is acceleration because it gives us a value of 10 meters per second squared. The units are the important thing. So the units right here tell us velocity. The units right here tell us acceleration. Okay? Now I want you to take a quick second, absorb. Then we're moving on to the next slide, which I think is the coolest thing in the world. Newton and all the scientists actually knew what they were doing. So we can take VF. So VF is 25. VI is 5. So VF, VI. The change in time, we go from 0 to 5. So our delta T is equal to 5. Remember all those guess method problems where we were given a VF, a VI, and a delta T? Well, we plug them in. We do 25 minus 5 over 5, and we get 4 meters per second squared. It's pretty much the same exact thing as if I were to calculate rise over run. So I'm going to do a lighter blue. We go run for 5 seconds. We rise from 5 to 25, which is 20 meters per second. And oh my God, isn't that the exact same as what we just did? 25 minus 5 is 20. So yes, in fact, this formula right here is the exact same thing as calculating the rise over run of a graph. So I think this is just super cool because it really puts it all into perspective. Nothing we do in this class is in a silo. It's not separated. Everything we do is connected. Hopefully this actually helps you see, oh, so that's why I was doing this formula. Or, oh, so that's why I was doing the graph. This is what physics is about. Physics can be shown in so many different ways, but they all are the same in reality. They're just done a little different. So, VF minus VI is the same thing as the rise. Delta T is the same thing as the run. Ta-da! Amazing. Science is something that people thought about before they just did it. So cool. So last thing, do the DOL. I want you to just do a rough sketch. It doesn't have to be exactly the same numbers. Just kind of draw what it looks like. And have a great rest of your day.